Welcome to another video of capital budgeting. In this video, we'll look at another example of net present value. Suppose there are two projects A and B. The investment outlay for both the projects is rupees 100 each. Project A returns rupees 200 after 1 year and rupees 50 after 2 years. On the other hand, project B returns rupees 60 after 1 year and rupees 200 after 2 years. At discount rates of 5% and 10%, find out the NPV of projects and their rankings. So let us first draw the time scale for these two projects. So here I have drawn the time scale for the two projects. As you can see, project A has a bigger cash inflow at the end of first year and a smaller one at the end of second year, whereas project B has a smaller cash inflow at the end of the first year and a bigger one at the end of the second year. So the main purpose of this example is to see how these different type of cash inflows at different times with different amounts behave when there are different discount rates when we are trying to find the NPV. So here we'll find the NPV for both the projects at 5% and then at 10% discount rates, and then we'll analyze the results. So let's first consider project A. So first we'll find out the NPV at 5% discount rate. Now what is NPV? So as we have seen in the previous videos, NPV is net present value. So it has present value and then net. So the present value says that we have to find the present value of all the cash flows, whether it is outflow or inflow. And then we have to find the net value of those present values. So we'll have to add all those present values up. Now, typically in a time scale, we represent the outflows as a negative sign and the inflows as a positive sign. So if we add all of them up, basically we'll get the net present value. So here we have a cash outflow of 100 rupees. So let's say the present value of this cash flow is PV0. Then we have a cash flow of 200 rupees. So let's say the present value of this cash flow is PV1. And then we have a cash flow of 50 rupees. So the present value is PV2. Now first we'll do the calculation for present values at 5% discount rate. So the NPV will be equal to the netting of all these or the summing up of all these present values. So PV0 plus PV1 plus PV2. Now PV0 is minus 100 plus PV1. So present value, we know the future value is present value into 1 plus I to the power n. So PV is equal to future value divided by 1 plus I to the power n. So PV1 is FV1 divided by 1 plus I to the power n1 plus PV2 is FV2 divided by 1 plus I to the power n2. So this is equal to minus 100 plus, now future value 1 is 200 1 plus I is 5%, which is 0.05, to the power n1. Now PV1 is being discounted for 1 year, so n1 is 1, plus FV2 is 50 divided by 1 plus 0.05 square, because PV2 is being discounted for 2 years. So now this is equal to minus 100 plus 200 divided by 1.05 plus 50 divided by 1.05 square. So minus 100 plus 200 divided by 1.05 plus 50 divided by 1.05 square. So this is equal to 135.82. This is in rupees. Now let us find out the NPV at 10%. So again, NPV is equal to PV0 plus PV1 plus PV2. So this is minus 100 plus 200 divided by 1 plus, now here instead of 5%, the discount rate is 10%, so 1 plus 0.1 to the power 1 plus 50 divided by 1 plus 0.1 square. So this is equal to minus 100 plus 200 divided by 1.1 plus 50 divided by 1.1 square. So 100 negative plus 200 divided by 1.1 plus 50 divided by 1.1 square. So this is equal to 123.14 rupees. So at 5% discount rate for project A, the net present value is 135.82 rupees. Whereas for project A, the NPV at 10% discount rate is 123.14 rupees. Now let's do the same calculations for project B. So again here we have to find the net present value at 5%. So let's say the value of the initial cash outflow is considered as PV0. The present value of the first cash inflow is PV1, and the present value of the second cash inflow is PV2. So NPV PV0 plus PV1 plus PV2. So this is minus 100 plus FV1 divided by 1 plus I to the power n1 plus FV2 divided by 1 plus I to the power n2. So this is equal to minus 100 plus, now in the first cash inflow, the FV1 value is 60. I is 5%, so 5 divided by 100 is 0.05. So 1 plus 0.05. N1 is 1 because PV1 is being discounted for 1 year. Plus 200 divided by 1 plus 0.05 to the power 2, because PV2 is being discounted for 2 years. So this is equal to minus 100 plus 60 divided by 1.05 plus 200 divided by 1.05 square. So 100, and this is negative, plus 60 divided by 1.05 plus 200 divided by 1.05 square. So this comes out to be 138.548 rupees. Now let's find out the NPV at 10% discount rate. So the NPV is equal to PV0 plus PV1 plus PV2. So minus 100 plus 60 divided by 1 plus 0.1 to the power 1 plus 200 divided by 1 plus 0.1 square. So this is equal to minus 100 plus 60 divided by 1.1 plus 200 divided by 1.1 square. So 100, and this is negative, plus 60 divided by 1.1 plus 200 divided by 1.1 square. So this is equal to 119.834. So 119.834 rupees. So for project B, the NPV at 5% discount rate is 138.548 rupees, whereas the NPV at 10% discount rate is 119.834 rupees. Now let's compare and analyze these NPVs for project A and project B at 5% and 10% discount rate. Now we know that the project having a higher NPV will get a higher ranking when we are using the NPV method. So here, as you can see, at 5% discount rate, project B has a higher NPV. So here, this is number 1. And at 10% discount rate, project A has a higher NPV as compared to project B. So at 10%, project A is number 1. So as you can see, the project ranking is reversed when the discount rate is changed from 5% to 10%. So why did that happen? Now in case of project B, the larger cash flows come later in the life. So if you recall, the cash flows for project A was minus 100, 200 and 50. Whereas for project B, it was minus 100, 60 and then 200. So in case of project B, the larger cash flow came later in the life. So because of that, the present value declined more as the discount rate increased. So as we can note, the impact of discounting becomes more severe for the cash flows occurring later in the life. And the higher the discount rate, the higher would be the discounting impact. So as you can see, project B then suffered because of the higher discounting at 10% and its larger cash flow being towards the end of its life. So that's why its NPV was lesser than that of project A when the NPV was 10%.